Hello, this is Matthew, and welcome to today's video, which is a bit random for the channel, but I don't know, kind of up the alley of what we do sometimes. And the reason this came about is because I was watching Dennis Clark's stream over on Twitch. He's Last Miles on Twitch. And someone in his chat said something along the lines, I'm going to get the exact quote wrong, but something along the lines of, I'd pay money for a video showing how to bootstrap or build from source GCC on FreeBSD, essentially completely from scratch, using nothing from FreeBSD ports. So I guess the rules would be you install FreeBSD, but then you're not allowed to install any additional packages or use anything from the ports tree. You just have to build up GCC from whatever you get from a base new FreeBSD installation. That's how I'm interpreting it in any case. And the good news is, I don't know if this person in chat realized this or not, but it's actually very straightforward because FreeBSD already comes with a current modern version of the Clang LLVM compiler suite. So if we just start with current FreeBSD, we essentially have everything we need. We would need to build a couple of tools. GNU make, the built-in FreeBSD make won't do it. The GCC make files and build process certainly use a lot of GNU make extensions. And then, in fact, let me just pull up the gcc.gnu.org website here. If you go to installation and prerequisites, it'll tell you need an ISO C++ 14 compiler. So the latest GCC now requires C++ 14 to build. Again, that's fine. The version of Clang in FreeBSD is going to meet that requirement. And then you need C standard library and headers. Again, that's fine. FreeBSD is a complete, both development environment as well as end user operating system environment. And then there's a bunch of caveats if you want to do the tests. You can't build the ADA support unless you already have an ADA compiler. You can't build the D language support unless you already have a D language compiler. But we're going to go for the main languages, C, C++. We'll throw Fortran in there. I think those are probably the big three that people will often expect out of a standard GCC build. If you're building for older operating systems or some other architectures, or if you don't have a modern, up-to-date C, C++ compiler already on the platform, that's really where it gets kind of more, fun, if this is your idea of fun, more interesting. So I've done things like under HPUX on PA RISC, where I only had a original ANSI C compiler. You actually go back and you start by building a very old version of GCC that could still be built by an ANSI C compiler. And then you build, maybe 3 major versions newer of GCC that then adds newer language support that the next 3 major versions forward of GCC might require, until you get up to the point where you have a GCC, like it says here, GCC 5.4 or newer has sufficient support. So you can build the current latest version of GCC 15 with GCC 5.4 or later. So basically you just start with a very old version that doesn't require C++ 14 and you work your way up. But we don't need to do that on FreeBSD. And like I said, there aren't really a lot of other prerequisites that will give us any trouble. So with that, enough talking. I blab a lot at the beginning of these videos. Let's just go ahead and dive in. So the first thing we need to build GCC on FreeBSD is FreeBSD. So I'll set up a FreeBSD VM over on this Proxmox server I have in my lab. And I don't think I have the ISO downloaded on this server yet. Yeah, it'd be F probably for FreeBSD. So you just go to the FreeBSD project website. We'll hit download, and I'll be happy with the just net installation image. So 14.2 release is the current production ready release. We'll just use the latest and greatest there. So this is going to be AMD 64, and we can use just the boot ISO. So I'm actually going to copy that link. This Proxmox server is not here at home. It's it's off-site, so you can actually tell Proxmox to download ISOs directly from a URL for you. So that should theoretically be a little faster than me downloading it here and then copying it over to this Proxmox server. So I'll just have it download, and it'll even, it's kind of cool. It'll unzip a couple of formats for you. Unfortunately, it doesn't have XZ built in there, which is the only other compressed format that FreeBSD offers, but they offer it uncompressed, so that's fine. It can also verify the hash for you. Do I care? Yeah, well, we may as well do it for just completeness here. So if we grab, okay, yeah, so here's the SHA-512 hashes. Let's see if this opens in the browser. Of course not. It'd be convenient if they made it, I don't know, .txt, so it actually opened in the browser. But let's take a look at that file. And yep, AMD64 boot only is the first one. So yeah, if I copy and paste this hash into this little box in Proxmox, it will verify the hash of the download. So kind of a cool feature. So then this will all just go out, and yeah, it's just using looks like wget to grab that. Check some mismatch. What did I do? AMD 64. Did I not copy and paste that correctly? What happened here? 3.5. Got 3.5A ending in. Did I think I picked up some extra. That looks awfully similar. Okay, hold on. What am I doing wrong here? 3.5A ending in 747.473. 3.5A ending in 747. Oh, it copied the space in the middle of it. Okay, yeah. So that was a copy and paste error on my part from that terminal window. Did it keep the file or did it? Nope, it rejected it. Okay, we need to fix that. So let's download from URL again. And I think I still have this in my middle click buffer. Nope, I don't. Let's grab that again. Grab that. And yes, delete that space. Okay. And we'll just use that as the file name. Try that one more time. There we go. Now it's happy with it. Okay, so now I have the FreeBSD ISO. Perfect. So I'll just make a new VM. We'll call this FreeBSD. And we will install from that ISO. It is not Linux, it's other. And so I think that just doesn't give me any options. This should all be good. FreeBSD does have virt.io drivers, so you can switch it back to SCSI. I'll give it, I don't know, about 64 gigs should be plenty. And I always just change the host to my actual native host processor. Let's give it, we're building software, so let's give it 16 cores just so we can, do make-J16. It'll go a little bit faster. And yeah, 16 build threads, let's say, we want to make sure maybe 2 gigs per core is available. So that would be what, 32 gigs. So that's 32,768 megabytes of RAM. And again, we can switch to the virt.io drivers because FreeBSD, or sorry, the virt.io NIC, because FreeBSD does have the virt.io drivers. And that all looks good. So it's creating that VM for me. And there it is, FreeBSD. So I'll install from the console here. And then once it's installed, we'll just SSH in. Let's see, boot the installer. So I'll just hit enter. Can I make this full screen so it's a little bit bigger? There we go. Okay. And close this little sidebar. All right, welcome to FreeBSD. Yes, we want to install. default key map is probably fine. Host name, we'll just call it FreeBSD. We probably don't need to debug the kernel. Yeah, we'll leave 32-bit enabled. Why not? And then we're not going to use the ports tree. So yeah, I think probably the only optional package, we'll just keep the 32-bit compatibility stuff. So because we downloaded the boot-only ISO, it needs to download the actual install packages from the network. So we'll configure the network adapter. Yes for IPv4. Yeah, DHCP, because this will just be a temporary machine for this video. Nope, no need for IPv6. That looks correct from the DHCP server. And yeah, we'll use ZFS. So FreeBSD is by far of all of the free operating systems the best integrated with ZFS. They don't have the licensing shenanigans with the CDDL, GPL incompatibility that the Linux world has. So FreeBSD was just able to take the ZFS code from back when it was open sourced by Sun and build it right into FreeBSD, and they've done a very, very good job of integrating it. So yeah, we'll just proceed with the defaults here. I only have one drive, so yeah, that'll just be a stripe on DA0. That's my virtual hard drive. And yes, I want to destroy that disk and install FreeBSD onto it. All right, any interesting mirrors? I'll just use their primary mirror here. Okay, so this is going to download the base system, the kernel, and then the 32-bit multi-lib stuff. All right, so we're installing it at about, well, we were 1,000. I don't know if you can hear that. The air show is this weekend, and the first one is Friday night. And I live very near an airport that they do the air show at. So if you hear really loud jets outside, those are F-15s, and I think later an F-35. Maybe not the best time to record the video, but I don't think it'll bother us too much. Okay, it's asking me to set the root password. And we can set the time zone. I'll just leave the system on UTC. That looks reasonable. Time and date are already correct. We do want SSHD. May as well keep the time synchronized. And do we care about any system hardening options? Oh, I don't know. I always like random PIDs. And yeah, just clear temp on reboot. And there's no reason for remote syslog sockets on this. Okay, no firmware that needs to be installed. And yeah, I'll add a regular user. So just my good old M. Wilson user. Default. We'll put it in the wheel group. So that may be required to use SU on FreeBSD. We'll use the SH shell. That's fine. Defaults are fine. No encryption. That's fine. Yes for password. Not an empty password. Not a random password. I will assign myself a password now. All right, lock out the account after creation. No. And yeah, that all looks good. Okay, no need for another user. We'll hit enter again. And that's it. We can exit the FreeBSD installer. Do we want a shell? And there was a high-speed passive eject. Do we want a shell? No, we'll just go ahead and reboot. So this should now boot from the hard disk. There we go. All right, so it'll auto boot in 6 seconds. We'll just hit enter to boot into multi-user mode, which is the default, of course. And that's it. We are up and running with our new FreeBSD system. So I will log in as root and check my IP address here. Okay, so 136. So let's get out of full screen mode here. So over in the terminal, was that 136? Yes. I should be able to connect to 192.168.64.136. And we're in. All right, so that was our base FreeBSD system install. We don't have a GCC. We should have a Clang. Yep. And the make we have is the BSD make. Does it have... It probably uses a... I don't even know if it has a version flag, but obviously it's using non-GNU style, non-long options, and there is no gmake. So I think all we will need to grab is obviously gmake, but that shouldn't have any prerequisites that aren't already in the base system. I'll probably grab binutils. Actually, let's look. Do they say anything about... so back on the GCC website, if you go to platforms, they'll have just various notes they've collected over the years for various platforms. So if I look for... Oh yeah, there's FreeBSD. So these are the sort of target triplets. So the architecture and the operating system here is FreeBSD. So it looks like they have some notes just for FreeBSD on any platform, any architecture. So it uses ELF. And that jet rattled my house. Okay, yeah, we recommend bootstrapping against the latest GNU binutils or the version found in port. Well, we're not allowed to use ports, so we are just going to download binutils and use it. Add and D libraries are broken on i386, but you can't actually build ADA without an existing ADA compiler, and you can't build D without an existing D compiler. So we're not going to do those. Like, we're going to do C, C++, and Fortran. That's kind of the main expected compilers from GCC. And then they're saying libgo is generally broken on FreeBSD. That's fine. The actual native Go tools have good support for FreeBSD, so you wouldn't really ever use C, or you wouldn't really ever use GCC Go. It's well behind, and it doesn't have the magical tool chain that the native Go tool chain has. Okay, so yeah, so we will use binutils. So let's just start gathering software here. I'll make a source directory, and we can get most of what we need from FTP. So ftp.gnu.org. Just log in as an anonymous, and it's all under the GNU directory. So we'll grab GNU binutils, and looks like 2.44 is the latest. Let's grab this file. Okay, and we said we wanted make, GNU make. So what do we have here? 4.4 looks like. Yep, so 4.4.1 is the latest. We'll get that guy. And finally, GCC. So unlike some of those other tools, there's a subdirectory for each GCC release, and GCC 15.10 is the latest. So let's see what's in here. There it is. We will get that. All right, so that's all we need from the GNU project's FTP server. Let's see what we have here. So first, let's do make, because I suspect binutils also requires GNU make. So we'll just tar xzf that. And that gives us a make directory. Typically, if software supports out-of-tree builds, it's usually a good idea to do that, because then you're just always left with a clean, untouched original source distribution. So I'll make a directory just to build this in. And then I can run, I like to use full paths for this. Modern shells and utilities, I don't think, have a problem, but there was a note somewhere I read in one of the GCC install instructions that said use full paths, not relative paths, when you're doing the configure script, the autoconf script for out of tree builds. So it's just a habit I ended up getting into doing. So we will run configure. I'm just going to install everything into an opt GCC directory. So that'll be a new directory, and then our build of the prerequisites and GCC itself will just all be under that directory. So when we're all done, we'll be able to add /opt/GCC/bin to our path to get access to these tools we built. And then the other thing I'm going to do is program prefix and set that to G. So that will call the binary gmake instead of make. And that way I can have this /bin, this path on my path, but I'll still have easy access to the BSD make by just running make. And then if I want gmake, I'll run gmake. So that's all we need for make. That should configure pretty quickly here. And then we'll just use the built-in BSD make to make that. And we can do -J16. That will use potentially up to all 16 of the CPU cores I allocated to this VM. And that was fast. So now, because that opt GCC directory, there isn't even an opt directory by default on FreeBSD. So I am going to, so what you would probably typically do is make a new ZFS file set for this. And I mean, in fact, why not? Let's, I need to become root anyway. So let's just use SU. Let me ZFS create, the mount point is going to be opt, and this is going to be zroot opt. And then I'm going to do the same thing. I'm going to make a GCC ZFS file set under that. Whoops, I deleted the wrong option here. Zroot opt GCC. Okay, so now I should have my opt GCC, and then this way I can, I can snapshot, I can do what I want independently just to this set of software that I'm building and installing. So up to you if you do it that way or just let it go into the root file system. Doesn't really affect the process here, but this is just a good sort of hygienic way to do it if you have ZFS available. So now under opt, we have GCC. Good. So I'm still in this make build folder here. I'm root now, so I can make install. Okay, that installed everything. So back as my normal user, we should have an opt GCC bin gmake. So let me update my path to add opt GCC bin. And now if I do which gmake, it'll find it. I can run gmake version, and we can see that I am running GNU make 4.4.1. Perfect. This is a very uninteresting build, so I can just clean up my build directory here. I don't need that anymore. And then again, I still have the pristine source tree, so if I did want to redo the build, or if I decided I needed different config options, I wouldn't need to re-extract, I wouldn't need to get rid of the source tree, re-extract it. Obviously not a big deal for a small source tree where I can just extract it quickly, but again, it's just good practice. Most autoconf based builds support out of tree builds, but some don't. So use it if you can, otherwise not a big deal. Now next up is going to be bin utils, so let's extract that. And same deal, I'll make a bin utils 244-build directory, change directory into that, and then I'll use my home source bin utils configure. Same prefix. We'll just, again, have everything under opt GCC. And again, I'm going to do program prefix equals G. So instead of making an LD command and an AS command for the linker and the assembler, it'll be GAS GLD. And then the actual GCC build process will be able to handle that, and it'll discover all of these things anyway. But that's really all we need for bin utils. So let's do that. And then we're going to use gmake so that we're using that new GNU make that we built. And again, I'll just give it J16 since I have 16 CPU cores available. And this shouldn't take too long. There we go. That was pretty quick. So again, I need to become root. Now, I still need to use gmake for gmake install. So let me just confirm su without a dash to do a new login shell on FreeBSD will carry over the path. So my new bin directory is still at the head of my path. So I can just type gmake install here and we'll install all of those as root. Back to my normal user. Now, if I list my opt GCC bin directory, you can see we got all of the bin utilities in addition to my gmake. So in particular, the linker and the assembler is probably what GCC is most interested in being able to use. So that's it in terms of prerequisites we need to build on our own. GCC does have some other prerequisites we'll talk about, and we'll get to those in a second. But to do that, let's go ahead and extract the GCC archive. And if we go into, that should have given us the GCC directory. Yep, so here's the GCC source tree. And if you go into this contrib directory, there's a script here called, where is it? It's called download prerequisites. There it is. So if we take a look at this, GCC requires GMP. This is an arbitrary precision arithmetic package. And then MPFR is a software implementation of floating point that also supports arbitrary precision floating point. And then MPC and ISL, I believe ISL is optional. It has to do, I'm just making stuff up here. And MPC may be optional as well. GCC is able to use it to generate certain loop code under certain conditions or something like that. You can read about it. And then it looks like it can also use get text. This is probably just part of its native language support, probably mostly for error messages, to be able to show you error messages in different languages. But in any case, the GCC build instructions and the GCC project highly recommend that you do what are called in-tree builds of these prerequisites. Now, if you're building a Linux distribution and if you're packaging this up for distribution through D packages, Debian packages, RPMs, that kind of thing to integrate into a Linux distribution, you'll see them not doing the entry builds. They will have separate GMP packages that's a separate D package or RPM package, and their GCCs will link against those shared libraries. That's good for distributions for a number of reasons. But because we're just building our own GCC, right? Normally, if I'm building a version of GCC that my operating system doesn't provide as a package, or in this case on FreeBSD, where we're not using Linux packages, obviously, FreeBSD ports does provide their own GCC. But right, if I'm just building my own, there's really no reason not to do the in-tree build, where the GCC build process will actually build these libraries as well, and then statically link them into your GCC binary that gets built. So again, unless you have a good reason not to, which I really never do, when I'm building my own GCC, I always take the recommended approach of doing the in-tree build. So how does that work? The way that works is you end up downloading the source code for all of these projects, and then you literally just put a directory called GMP in the root of the GCC source tree and MPFR in the root of the GCC source tree. And when it sees these during the build process in its own source tree, it will build that local version and just do it all automatically for you. So to do that, you have to download these prerequisites, and they provide this script, download prerequisites, that does that all automatically for you, extracts them, names the directory to what it expects, which again is just GMP MPFR without the version numbers. But this script doesn't really work on FreeBSD. It knows how to use either wget or curl, but FreeBSD ships with a utility called fetch. It does not include wget or curl in the base install. Of course, you can install them from ports or you can build them yourself. But since we're not installing anything from ports for the theme of this video, and there's no reason to waste time building wget or curl from source, we can just use the built-in FreeBSD fetch utility. And then it also tries to use just a program called SHA-SUM, which you pass in an algorithm for to check the hashes of those downloaded files, whereas just the bare SHA-SUM isn't in FreeBSD anymore. It's there's basically just a program name SHA-512-SUM or SHA-256-SUM. So we'd have to fix a number of things in the script. It'll be easier just to do it manually. So let's grab, this is really what we want. We need to know the files to download, and then the GCC project hosts them all in this directory. So let's go back here, and let me just make my own little download script. And what I'm going to do is I'll just say fetch. Actually, we can just do it this way. We can see fetch base URL slash. Actually, we don't need the slash because the slash is already there. So it'll be base URL GMP. And then 1, 2, 3, 4 more that we're going to do here. And we can do the same thing for MPFR and MPC and ISL and get text. Oops, I don't want that there. I want that there. I want a blank line there. Okay, so let's add a to the beginning. So this should work, right? So this is just going to set those variables, download each of those into our directory. Yeah, that should be fine. So we'll run that. Perfect. Okay, so it's downloading this prerequisites. And then we just need to extract each of those, and we'll just use symlinks to the name. So the first one is a BZ2, so that's tar xjf. Grab that name there. And that's going to give us, as you can see here, a GMP 621 directory. So we'll just link that directory to GMP. Next up will be MPFR. So again, tar xjf for a BZ2 file, MPFR. And then we're going to get that directory name. So we'll call it MPFR. And MPC is a gzip archive. So xzf MPC. And link its directory that we got to MPC. ISL, almost done. Get the directory name correct. And xzf for get text. Right, so now you can see we have MPFR, MPC, and then whatever the other ones were. Where'd they go? There's ISL, there's GMP, there's get text. So because these source directories exist now in the root of the GCC source tree, the GCC build process will notice those, use them, and then build GCC with the version of these utilities or these libraries that it actually builds as part of the process here. So with all of those prerequisites in place, we will make our GCC build directory. So I'll just call it -build. And again, I'll use the complete path to source GCC configure. Now, I should say, let's go over to the website for a minute here. If you look at the installation instructions under configuration, there are a lot of configuration options for GCC. So the vast majority of these you never need, you would never set. But the kinds of options that are here, these are nice. This can let you set, if you're building your own version, again, particularly if you are building it to distribute, you can embed your own URL to report bugs in your build of GCC. You can include your own package version string. So if you say GCC-V, it will tell you, GCC, the version, and then built by Matthew. And so, anytime you get the GCC from your operating system vendor or from a package, it'll usually have these set so that it's directing users of that build to the provider of the build, not directly to the GCC project. But then you're able to set, what you're building it for. It should pick that up by default on most platforms, so we won't need to set that on x86 FreeBSD. The typical configure options like prefix, I believe they do. Yeah, they support program prefix, those kinds of things. But then you're able to get into things like which languages you want to build. That is a major one. So that's where we'll say we want C, C++, Fortran. You can do Objective-C. You can do Objective-C++. Brand new as of this version of GCC 15.1, there's initial COBOL support for x86 and ARM only. But anyway, this is where we'll tell it that, okay, yeah, we are using the bin utils AS and where it is, things like that. And then you get into things, multi-lib support. So again, platforms support this in different ways, but if you're on a 64-bit system that also supports 32-bit applications, that's what multi-lib is. Again, on FreeBSD is such a mainline platform that this is all just going to work on FreeBSD. We don't need to specify really hardly anything at all. You're able to specify things like the default CPU. So when you are building a program with GCC, there's things like GCC-march equals, and then the x86 architecture level. And so you can tell the compiler you build to default to what would otherwise not be the default architecture, all those kinds of things with Arch. And it's going to vary depending on the CPU type you're using. So you'll see these instructions are basically for all of the different processor architectures that GCC supports. So if you're interested in all of that and tuning your GCC to specifically a narrow use case for a particular system, there's a lot of stuff you can control here. You can control the floating point ABI it uses on AIX on power systems, right? All of that are here in the configuration options. But we don't, like I said, we don't really need any of that. We might use package version just to indicate that this is a build that we made here. So you can read the docs if you're interested in more of that. But we'll do a pretty simple configuration here. I will split it on multiple lines though, just so it's a little bit more readable. So I'll put a backslash here. So we'll say prefix is opt GCC with our other utilities. We'll do that. Did I include the dashes? Yeah, we'll do the dash with package version, and I'll say something like MRW, just my initials, and this is my 2025-05-16 build. We'll say enable languages, and this is where I comma separate C, C++, Fortran. I don't think we need Objective-C or Objective-C++. That's probably good. You're always going to get this thing called LTO. I think this is the link time optimization. But if you don't include it explicitly, GCC will just always enable it because it uses it itself. So you don't need to list that. But yeah, that should be good for now. And we'll say, yeah, so with AS, and I'll point it at that binutils AS that I compiled, which is in opt GCC bin gas. And that is, I think there's this option to tell it that that is indeed the GNU assembler. I don't think you actually need to include that option anymore with GNU AS. Yeah, so it only matters on HPPA, PA risk, and then Solaris 211. So on any other system with GNU-AS has no effect. Okay, so we pointed it at the assembler we want it to use, the GNU assembler. We don't need to tell it that it's GNU-AS. And I think it's the same for with GNU-LD. Yeah, same as with GNU-AS, but for the linker. So we're going to point it at the linker to use. It doesn't need to then also be told that it is, in fact, the GNU linker. So I'll just remove that option because it's unnecessary. But same thing, GLD is our linker. I'm trying to think, are there any more other options we want to give it? So we're doing configure, install it there, stamp it as our version. We'll take C, C++, and Fortran. We point it to our assembler and our linker because the recommendation on FreeBSD was to use the binutils utilities. So that should probably be all we need just for this simple build. Yeah, so I'm just going to hit enter here. This configure is pretty fast because it really isn't doing much. It's it'll run the configure for all of the various subcommands and projects as part of the build. So that's it. We created the make file. Now I'm going to use time just so we can see how long this actually took. And when I'm running a big compile job, I like to just run it as nice, so it'll run as a lower priority than normal processes. Really no reason to give it a specific nice level. By default, nice will just increase the nice level by, I don't know, 5 or 10. Again, it's going to be a lower priority process than any processes I start without nice. And we can just run gmake. I'll give it -J16, so it'll be able to use all my processors if it wants to. And then the way you can keep a log of your build, but still watch it go on screen is we'll redirect standard error to the file descriptor 1, which we will then all pipe out to T. And I'm going to go up a directory level, and I'll just call it this .log. So if something goes wrong, if we need to look into the build log that's going to go flying by way too fast to see as it scrolls on the screen here, we'll have a copy of that in that log file. So I'll hit enter there, and it's going to start building, and this will take a while. So the way the GCC build works is it does what they call a 3-stage bootstrap. So it's actually going to build GCC, the compiler at least, 3 times. So this first time, it's building GCC with your system compiler. So in this case, this is where we're using Clang that came with FreeBSD to build GCC. It will then use, and so that's the stage 1 GCC. It will then use that stage 1 GCC to once again build GCC. And the reason they do that is because there may be some idiosyncrasies or vendor-defined behavior or anything like that in your system your system compiler. So Clang in this case. So they want to build the GCC source code with GCC itself because all of the testing they do on GCC is based on GCC having been built by GCC with full support for any GNU extensions that they're using, all those kinds of things. So they use that first GCC that was built by your existing host compiler to build GCC again. So that first GCC built by GCC is the stage 2 GCC. And then one more time, they use that GCC. So now you have a GCC that was actually built by GCC. So it should work the way they expect GCC to work. they use that stage 2 GCC to build GCC one more time. That's the stage 3 GCC. And then they actually compare the stage 2 GCC with the stage 3 GCC to make sure that GCC is actually building itself reliably and repeatedly, right? If I build GCC 2 times with GCC, the same version of GCC, I should get the same output. And so that's the 3-stage bootstrap. Stage 1 is built by whatever random C compiler you're using to start out with. And then they use that built GCC to build GCC to make sure that they're actually getting a repeatable build of GCC. Once that happens, once it passes the stage 2 to stage 3 comparison correctly, that's when the build will then move on and build additional ancillary stuff. The final copy of the C++ standard library, the final copy of libgcc, additional tools, and some other things that they don't need to, run through the 3-stage process. At this point, they trust the stage 3 compiler is a correctly built and correctly working GCC, so they can build that other ancillary stuff after that stage 3 compiler is built. So that's what's happening now. We're building the stage 1 compiler at this point still. But on this system, I'm guessing will run probably about an hour, maybe a little less. So I'll just pause the recording here and I will come back and hopefully this will go through without any errors. Again, I expect that it should because FreeBSD is, especially on x86, should still be a pretty, top tier supported platform by GCC. And we're starting with a new enough Clang that even, any little GNU-isms in the GCC stage 1 code here, I expect Clang handles just fine. They try and match really most of the GNU extensions just so that Clang is a pretty reliable drop-in replacement for GCC. So with that, I'll pause here and we'll come back when this whole compile is finished. And we're back. So that did finish without errors. That's good. And it wasn't too bad. The real time, so this is the actual wall clock time in seconds that it took. We can pull up, let's go 2402 divided by 60. So 40 minutes, so not even an hour. So really, yeah, not bad at all. Just a little 16-core VM on a several years old Xeon processor. So since that worked, we'll just do the make install. So again, I'll switch to root. And remember, we need to use gmake. That's our GNU make. And that should put everything into place. There's a lot to put together and install for GCC. Okay, we're all done. So let's see what we got. Let's look in our opt GCC bin directory. Okay, so these are the GCC bits. It always installs copies with the target triplet. But if we also just look up, we have our regular G++, the C preprocessor. There's GCC. It has its own archiver and why is the full name of NM escaping me at the moment? Anyway, the symbol name management, all of that. So that's all there. And because it's on my path, if I just say which GCC, because remember, we still have opt GCC bin at the front of my path. Let's try it. Let's make a hello.c. So we'll just do a printf. So we just need standard IOH, int main void, printf hello world from GCC on FreeBSD. Okay. So a little C program. So we can say gcc-o hello, and we'll build hello.c. Well, so far so good. We got our hello, and if I run it, it works. Hello world from GCC on FreeBSD. And if we look at it in terms of libraries, right. So yeah, so a simple C program, of course, just depends on the system libc. So that is all working. Now, I suspect, in fact, let's see if we can do this. So if we have a program, let's try a C++ program. So let's do hello.cpp. My C++ is a bit rusty, but I believe we want to do something. What's the standard? It's IOStream, right? And then we can say int main. I'll just say void again. And so now if we send a stream to, or if we send text to the cout stream, hello world from C++ on FreeBSD. I think that's right. Standard cout. Right. Excuse me. So this is going to use the lib standard C++ stuff. So let's go ahead and compile that. That's going to be G++-O. We'll just overwrite our hello executable. And we're going to build from hello.cpp this time. What did I do wrong? Oh, IOSteam. That needs to be IOStream. IOStream. Okay, that builds. We got our hello, and if we run it, aha, okay, yes. So I suspected this would be the case. Now, this isn't unique to FreeBSD. This would happen on a Linux system if you didn't have a system-wide GCC installed, or you didn't already have any packages installed that had pulled in GCC's C++ standard library. You can see it's looking for a shared object here that it's not finding. And again, that's because typically, if you ever installed a package on your system that was built with GCC and depended on GCC's implementation of the C++ standard library, it dynamically links to that. And so this lib standard C++ would likely already be in a location on your system that the runtime linker and loader, the dynamic library loader, knows how to find. So again, on most systems, that'd be, user lib and lib. But because we installed GCC under opt GCC, in fact, we can find, let's just search the entire opt GCC tree for that file name. Yeah, there it is. Our standard C++ shared library is under opt GCC lib. And then we also got a 32-bit version because this GCC was built with full multi-lib support because we installed that 32-bit compatibility library when we installed FreeBSD as well. So anyway, that's neither here nor there. But the library is here. There is no user lib standard C++, right? There's nothing like that there. And this is actually something, if you build your own GCC on Linux and put it in your own directory like this, and then you start building C++ applications, they'll probably run because you may not have realized that at runtime, it's linking against the lib standard C++ that was built with your vendor or distro provided GCC runtime. So if your intent was, you want the latest and greatest GCC and you're trying to test, changes in GCC's implementation of the C++ standard library, for example. So you built your own GCC, you installed it in your own directory, you built your program with your GCC. But be careful at runtime, it's probably not using your freshly built shared library. It's probably using the system-wide library in user lib or something like that. So with that background, how do we fix this? What do we do about this? Well, the FreeBSD runtime linker is very similar to the Linux and Solaris runtime linker. As you move to some other Unixes, things get a little different. I'm thinking AIX, but it's very similar. So, what you would do on Linux a lot of the time, if you're just trying to, just get this to work, is you would set your LD library path environment to the directories you want to search for libraries. So if I say LD library path equals that, and then I run my hello, all of a sudden it works. And if I say LDD hello, you can see that it's going to find the library in your library path search order. And you can see libstandard C++.so.6 is under opt GCC libstandard C++ SO6. If I just run LDD without that, it can't find it. Interestingly, it is using a libgcc_s that comes system-wide. So that does ship with FreeBSD. But, I'm guessing we'll also have under our opt GCC libgccs star. Right, so we built our own. So that was an example of, assuming the program ran without libstandard C++, if it just had a dependency on this libgcc_s, it would end up running, and at runtime, it would use the functions in that library that shipped with FreeBSD, not the GCC we just built. But again, if LD library path is set, it's going to prefer the one in LD library path. But LD library path, and people may disagree with me on this, but LD library path is ugly. And if you ever have to set it, that means your software was not built correctly for the system you're running it on. Right? I would state that you should never have to set LD library path. Instead, your software should be built correctly for the system that you're running it on. So what does that mean? There's an attribute in ELF, so that's the executable format for FreeBSD, for Linux, for Solaris, for a bunch of Unix and Unix-like operating systems, called the RPATH. Classically, there was also one called RunPath, but it put it too late, so you couldn't override system-wide. So that's a different discussion for another time that doesn't really matter. But there's an attribute called the RPath that can actually be baked into the executable. And that says for this executable, it tells the runtime linker and loader where to look for the libraries that this program depends on. So if we do, is it read elf? I think it's read elf-a. If I look at my hello program, yep. And in fact, there might be I think the -d option will be more specific to what we need. Yeah, so if I read elf-d hello, you can say that we need these shared libraries, but they're just file names. They're not paths. So the system is going to try to find, according to its rules, where these libraries are. And in our case, FreeBSD is looking in /lib and /userlib. Now, there's no run path here, right? There's no directories here saying, by the way, when I built this program, this libstandard C++ was in /opt/gcc/lib. So when I try and run it later, it's failing. What we can do is when we build the program, the linker has a command line argument where you can tell it what you want to set the run path to, or directories you want to add to the run path. So if I'm building this program to run on this system, I want this program to have built-in knowledge that it should be looking in /opt/gcc/lib as its preferred location to find libraries before it then starts falling back to the rest of the normal search order. And here on FreeBSD, at least, the option to LD that will work is -r with a directory argument. I think --RPATH might also work. But if you give -r a directory, it has the effect of setting the RPATH. So how do we do that from here? So if I do GCC again, or actually this is G++ because we're going to build the C++ application. So same thing, I want it to output to an executable called hello. There's this -WL parameter that takes kind of a funny format, but this says pass the following argument list to the linker. Because GCC and G++, these are really driver programs that run a number of programs behind the scene. So when I run G++ on a C file, it's actually behind the scenes running the C preprocessor. It's taking the output from the C preprocessor and running it to the C compiler to generate an object file. And then it's taking all of the object files that I build, passing them to the linker to actually make that executable. So one of those steps that it's running is it's running the linker behind the scenes. So if I want to if I want to pass command line arguments to the linker, I can use this $W lowercase l command. And then you separate the arguments that'll go into the argc var args. If you think of it, you're writing a C program that receives arguments with commas. So here I can pass it that -r option and give it /opt GCC lib. So this option is going to be passed to the linker when G++ is taking the object files it compiles from the C++ file and uses LD to put them together into an executable program. And again, I give it the command hello, or the file name hello.cpp. So if we do that, now let's just see if it works. And sure enough, it does. And you should now know why that works. If I do LDD hello, it finds it in that location. And you can see I'm also now using my newly built libgcc_s shared library. But then for the libraries that weren't part of my GCC build, the actual system libc and the math library, it's going back and it's finding those in the normal search path. So once again, we can do readelf-d on my newly built hello program. And this is the key to why it's working now. The RPATH parameter value in the actual executable has this library path. So it's first going to look for the required shared libraries under this path. Now, that's all well and good, but I don't want to have to remember to do this on everything I build with GCC or G++. And if I'm just running the make file of other programs I've downloaded and it's using my GCC, I don't want to have to set up my LD flags and all of that to do this. So there are two options you have. Again, we're not setting LD library path. That's currently blank, right? LD library path means that you took linked executables from one system and moved them to another system that has the required libraries in different places. And again, that's the wrong way to move around and install software on really any Unix or Unix-like system. What we can do is there's an environment variable called LD. Let's see. I think it's called LD run path. Let's try this. I might be remembering that wrong. I probably should have written this down ahead of time. But if we set this, I'll set it to my opt GCC lib. We'll export LD run path. Now, this isn't LD library path. If I run my hello, or actually let's build a broken hello again. So -o hello.cpp. Why did that work? Oh, yeah, because I already set LD run path. Okay. This was a bad example. Let me remove that. Let me unset ld run path. So now let me build that again. And if I run hello, okay, so this is my broken hello. It does not have any kind of run path inside of it. Now I'm going to set ld run path. Now, hello will still be broken, right? ld run path is not a substitute or a synonym for ld library path. What ld run path is, it just means at build time, when you're actually using ld to assemble objects into an executable, the ld tool itself will include the value of ld run path in the produced executable's RPATH. So does that make sense? So if I now, remember, I have my broken hello that does not have an RPATH set. And again, setting ld run path at this point does not magically set RPATH at runtime for existing binaries. But if I remove that broken hello, and now if I once again build with G++ with just -o hello, hello.cpp, now, because ld run path was set at the time ld was invoked, that RPath is now baked into my final executable object. So I can unset ld run path at this point. And of course, it's still in the executable, and hello still works. So neither ld library path or ld run path are set. And I'm able to link to that library in my custom /opt/GCC build directory. Okay, so now I at least have an executable that I would say is built correctly to run on this system against the libraries I intend it to be linked against. But again, if I'm just a user on the system and I see that there's a GCC installed there and I just want to, set my cc equals opt GCC bin GCC, or CXX to the G++, having to set and, remember to keep this ld run path set is less than ideal. And the other problem with ld run path is if I then also build software using a different GCC or using the clang that comes with FreeBSD, I assume it's calling out to LD to do its linking. I will now perhaps accidentally be building software that's pointing to my custom little GCC directory, and I probably don't want all of the software on my system built with a baked-in run path pointing to my build of GCC's libraries. I only want my GCC to point to those libraries if it needs it. So the real way to do this, or at least the way I would do this, and the way I do it when I have custom GCCs that I build and install in what I'll call that non-standard location. So when I'm not using the system-provided compiler or the system-provided GCC, you can actually tell your GCC what commands or what command line parameters you want it to include or run when it's doing different steps of the build. So again, remember I said those programs, GCC, G++, these are just driver programs that are running other programs behind the scenes. And these build up the right command lines and everything else to go through the entire compilation and linking process for whatever it is that you're asking them to do. And all of that is configurable in these thing called spec files. So in modern versions of GCC, the spec file is built in. There's a default spec file built into GCC. And again, I'll keep saying GCC, but that includes G++, it includes G4tran, all of the compilers in the GCC compiler collection. So if I want to change those spec files, I can actually put a file in the right location to override the built-in spec file. And that location is, let's look under opt GCC lib. There's a GCC directory under the lib directory, and there will be the target triplet and then the version of GCC. And if you put a file called spec file, I think that's, yeah, just singular spec file, you should be able to override the specs. And let's see, is it spec? It's not spec file, it's just specs, plural specs. But we need a complete spec file. So how do we get that? Well, it turns out GCC has a parameter called dump specs. Yep, there we go. And it dumps out its entire built-in default specs file. So as root here, because this is only a root writable directory, we can say GCC dump specs, spell it correctly, and then I'll write that to a file called specs. Now, if we edit this file, here's how you see, or here's where you can see for these various different tasks that GCC performs, what command line parameters it's choosing, where it's passing in arguments. And so obviously the spec file here is a pretty advanced topic in terms of working with GCC. But what we're interested in is the commands it's going to use to link. So if you search for link underscore, and we can go, and what we're looking for is link libgcc, right? So this is an example where it's needing to link to that lib standard C++. If you were using some of the Go or some of the GCC languages that have their own runtime libraries, like GCC Go, like GCOBOL, the new COBOL compiler in it, this is where you control what options it's going to pass to the linker to include that library. So to be honest, I don't know what the %d means. I'm guessing this is the actual name of the library. But what we want to do before that is just say -r/opt/gcc/lib. Now, again, we're not using that -wl comma r thing because this is the actual parameter it passes to LD. When we say -wl to the driver program, whatever we tell it after the comma is essentially what it's passing through to LD. Whereas here, this is the spec file that's telling it how to run LD. So we give the direct argument as we want it passed to LD. So let's save that file. So again, we created the specs file in opt GCC lib GCC, and then your platform in the GCC version. And GCC will now use this specs file instead of the specs file built into the binary. So let's try this all out. Let's remove, oh, I'm still root. Let's be my normal user. Let's remove hello. Let's make sure, let's see, is LD run path? Yeah, so neither LD run path nor LD library path are set. So before, if we ran g++-o hello.cpp, we would get a binary that didn't run. But now, the g++ driver, when it gets to the linking phase, it's including that extra -r option to the linker that's going to set the R path in the executable. So if all of this worked, sure enough, hello world from C++ on FreeBSD. So if we do our readelf-d hello, you will not be surprised at this point to see that the R path is set. And so this executable, this hello that we built on the system with our GCC G++ compiler, runs on this system without having to set LD library path, without having to modify the global library search path. So if we're building programs with our custom GCC, our programs will now use the libraries from our custom GCC. So if you've maybe built your own GCC before, installed it in your own custom location, then maybe you're aware of this, maybe you're not. But hopefully useful knowledge if you were not aware of this before. And I think with that, we can say, we have a GCC that we built from scratch that is fully working, fully functional, and can be invoked. I will just use our C version again. Hello.c can be invoked by a regular user without that user having to know to set any weird special environment variables. And our programs work. And they build the software correctly to work on the system using our custom build. So I think we satisfied the original request there. We built GCC from source without using any FreeBSD ports packages or the ports tree on a default basic install of FreeBSD, and it's all working. So hopefully that was interesting. Hopefully that was enjoyable. Let me know if you all have any other thoughts on my edict that if you ever have to set LD library path, that means your software was built incorrectly for your system, and that the correct way to move software between Unix systems is not to copy binaries that depend on libraries in non-standard locations or standard locations without the run path. You'll note, for example, that commercial, so ideally you're using free software and you are building that software on your system for your system. But if you look at commercial Unix software, say the Oracle database, if you've ever run the Oracle installer, it doesn't ship the Oracle executable. It ships the libraries, the object files, and then it links them on your system. And so that way it is linking them on your system for your system, because you say what you want about Oracle, of course, but at least the Oracle developers know that setting LD library path to run a binary that you copied from another system and has its libraries in a non-standard location is not the correct way to install and run software on Linux. So they ship object files and their installer links them together. And that way they're linked against your version of the system-wide runtime libraries. So, right, they're not dependent on a specific version of libc, for example, or glibc on Linux. They're not dependent on specific versions of the incursus library on Linux, because they link, when you install Oracle, they link against the versions that are actually on your system. And then also they're able to link against their own libraries in whatever directory you install Oracle to. So that's an example of if you don't have the source for a program, but you are distributing a commercial program on Unix and Unix-like systems, the right way to do it is to ship the objects and then do a linking step as part of your install on the target system. But anyway, that's sort of a side note to all of this. Let me know if you agree or disagree. You're like, no, Matthew, you're dumb. Just set a LD library path and be done with it. But again, right, then you're potentially, if you then forget to unset it when you run your next command, you're potentially pointing other programs to the libraries that you didn't mean to point them to, right? So set the RPATH, build your programs correctly for your system. Anyway, yeah, argue about that if you want, but really there's no argument against that. Just do the right thing. And like I said, when you're building your custom GCCs, and this could be on FreeBSD, it's exactly the same on Linux. The spec file is the same on Solaris. If for some reason you're still building GCC on Solaris, put it in a custom location. Again, the Linux, FreeBSD, and Solaris linker and runtime loader, I should say, are very, very similar. But that's how you do all of that. So hopefully it was interesting. Hopefully I can find the person who had actually asked about this in the first place and let him know this video exists. But until then, I will see you in the next video. Thanks so much for watching. Bye-bye.